Thank you so much. So, hi guys. My name is Taran, as you can see, and today we're going to talk about Azure and specifically about its cognitive services. A little bit of introduction. In nowadays world, AI and machine learning, AI in general, is everywhere. It's on our smartphones, it's everywhere in internet. This thing can recommend us movies and other stuff that we might like. Somebody thinks it's a kind of hype theme, but me personally, I've got interested in it, and I really wish to learn it, to get started with it, which I did, so you can call me a hipster if you like. So, anyway, I moved a little bit further in this theme, and my main goal for today is to share with you guys my findings, so your journey in AI, machine learning in Azure would be much easier, and just to give you some point to start. A quick reminder, what exactly is machine learning? So we can describe machine learning as a set of techniques which allows machine, our computers, programs, to learn from existing data to use it in the future, to predict things, to detect anomalies, but it's all about data, actually. And machine learning used for a lot of different tasks, actually, and all these tasks can be classified to some groups. There are several of them, but just to name a few, a classification task. So this is typically when you need to classify things. Is it class A or B? Is it dog or cat? These kind of things. So it could be binary classification when you're just saying true or false, or multiple classification like you try to classify among several classes. Regression task, it's all about more like predicting future, again, based on some data, like, for example, what price will be for some group of product in a month or in a year. Deep learning is a separate subset of machine learning, and it's used in much more complex tasks like language understanding, like image recognition, and this kind of stuff. And why, again, just a quick look why it's deep learning, because it uses a huge neural networks which has a lot of hidden layers in it. And there are much more and more these tasks. And today, again, we're going to talk about more about Azure. So as we all might know, Azure is a Microsoft cloud platform that gives us a lot of cool stuff which cloud could provide. And specifically, it provides us with some predefined, pre-built model that already solves some machine learning tasks that we might need. There are 5 main groups of these kind of services, and we're gonna have a quick look on all of them. So, why should you use it? Why should you care about or know about it? So, first of all, it's cloud-based, so which is gives us a lot of, it's on a cloud, you don't host it, it's auto-scalable, it can handle massive amount of load, and so on, what cloud computing can provide us. Second thing, it's really easy to use. Technically, all these services is nothing more than a simple REST API, simple REST endpoints, get, put, post, delete, and so on, which we all familiar, I hope we all familiar with, and we can use it. And also what is important is, again, this is kind of already typical machine learning tasks that already solved. So what I mean, for example, you need to extract face from a photo for your business case, to solve your particular business problem. So you don't need to have deep knowledge in machine learning, data science, and so on, and you don't need actually to spend a lot of time to solving this task, because this task already solved by other people, and you can just use it to solve, again, your particular business problems. And it's relatively cheap. So let's go to some demos. And again, so let's come back a little bit to this slide. We have 5 big groups. So it's vision, speech, language, search, and knowledge. Let's have a look at all of them. So I have a small demo. And here I would like to show you vision services. So I'm going to show you 2. It's optical character recognition. What it does, again, for example, you need to extract a text from an image. For this, you can use OCR service. So again, let's have a look. So choose some file. It was here, OCR demo. So for example, we have this picture. Some chat, like messages, hey, you're not answering, yeah, just dropped my phone, okay, then. So for example, we need to extract all of this. I just uploading this image to an OCR service, and I get the response. So you can see that this recognized, so this is actual response from a server. So it recognized a title, it recognized these buttons, it recognized some times, so it's actually pretty accurate. And here at the bottom you can see a JSON response, so I printed it for you to see it. So it has some different meta information about like language, text angle, some regions of a text that it found, and again some bounding box, so you can draw lines, for example, if you need, around the text. And to do so, we need a simple API call. So this is my endpoint, which is calling OCR. Again, we are defining URL. All cognitive services has, obviously, URL. All of them required authorization key, which you should take from Azure. So in Azure, you have a special type of resource called cognitive services, where all your keys generated. And I'm posting my data, I'm forming my request according to what service expect from me. And I'm receiving JSON response, which is provide. So you see a single API call, and we recognize this text. Another vision service that I would like to show is Face API. So what I mentioned previously, you can extract faces from an image. These services provide you a wide range of functionality, not only face extraction, but it can tell you exactly, for example, what a mood of a person are. It can tell, for example, it can identify known persons on an image. So what I would like to do here, I would like to provide it an image. So this image, faces, strangers, this one. I already pre-trained my model to recognize Iron Man and Captain America from Avengers. So what I basically did, again, using REST API, I created a group, that's called group of known person, called them Avengers. And I provided just a few examples of images. So like this, for example, like this. So we could learn and understand what known person is. And let's have a look at this. So let's have a look at code first. So what I'm doing here is I'm retrieving my groups from a remote API which I stored. I'm retrieving all persons from this group. And again, this is a simple REST endpoint, like get with some parameters, post with some parameters, and so on. Then I'm sending a request for detecting the faces. To detect the faces, you don't need any groups or this kind of stuff. You just post a byte array with the image, and so API can extract a face from it. But why do I need it in the future? Because I want to provide this detect result, these detected faces, to for my identification result. So service could tell what exact persons on that image is. And let's see it in action. So I click Recognize Faces. And you can see that among all of them, it could recognize only 3, so not all of them, obviously. And it did recognize so a person's which I provided here. So here we can see Iron Man, thinking that it's Iron Man with approximately 69% of confidence, and Captain America and 64% of confidence. And Thor remained as a unknown person, and these 4 remained like not recognized. It's not perfect, but it did some good job, which might be enough for my particular business case. Again, here you can see a response from detect result. So you can see that it sends me a face ID, which I can query from this service. Face rectangle, so I could draw these rectangles around face. And if it can, it will provide you with other meta information, like where is the nose is, where is the ears is, and this kind of stuff. And vision services, so these two, what I show, not the only ones. There are also services which can detect landmarks, some celebrities, which can, so you provide this in image and it responds back with like what it could recognize from it. So for example, if I take a photo of this room, it will send me back like some text, like people, maybe presentation, big room, and so on. Next thing that I wanted to show is searching. So we can use intelligent search provided by Microsoft. It's all based on a Bing. I assume all you know a Bing, it's like a Google search engine, but from Microsoft, so Bing search engine. And it also leverages some intelligent capabilities. So it's not searching just by contains, it can be smart. So 2 things that I want to show here. You can use Bing auto-suggest. So when I start to type here, I will send request for auto-suggest to a Bing. And again, this simply is get request with headers and my query parameter and some other meta information. It will retrieve me a list of things it think I might interested in. So for example, I'm typing and we can see that it thinks that I'm interested in Avengers, Infinity War Online, Infinity War full movie, and so on. Yeah, why it's, you might laugh, why it's Española? Yeah, that's easy, because I provided a local, so market for a Spanish market. I just copy and pasted the wrong locale. It should be in English, but we can see that Spanish works as well. And again, you can see some a plain JSON response. So what it responded to me. And let's see. So for example, Avengers Infinity War full movie. What we can see here, a web search. So now I'm using a Bing web search. And again, this is one of the simplest GET requests. It provided me if it can, it will provide you web pages that it found, some groups, web pages, images, news, and this kind of stuff. So we can see that it found some web pages, it doesn't found any images, found some news, non-video, and some related search. So if I, again, I can use this to navigate. So that's actual search result. So if I go here, I see some, oh, this is maybe some official website. Okay. And in general, you can search by these 4 things separately. You can search separately by news, by images, and all that we've seen here. The other thing I wanted to show you is language services. So, as the name says, these kind of services will help you to deal with usually natural language input. And particularly, I want to show you LUIS, Language Understanding Intelligence Service, with which I personally worked in production. So I'm pretty familiar with it. What it does, let's go to LUIS admin portal. So yeah, some of Cognitive Services has an admin panel where you can go, so it's just a simple website when you can manage all your data, your entities, and other kind of stuff. So first things I see here is my apps. It's actually classifiers. So yeah, what LUIS about? Yeah, I forgot to say about it. For example, you type some text, some free-formatted text, user types some free-formatted text, and you would like to know what person actually want to do. And to be able to do so, you should use LUIS. Again, this is a classifier which is works like that. So you create your classifier application, things that can classify user input. I already created eShop request classifier. So let's imagine that we have some eShop when users can send some requests to support. And what we would like to do is to optimize human work to, for example, if there are some questions that doesn't need a human interaction, we can use LUIS for it. So we would like to automate it. And I defined 2 intents. So what intents in a LUIS terminology is actually that things that I want to do. So I defined buy item and support request. So for example, people type in, I want to buy a car. So obviously it should recognize that person would like to buy a car, and our application should react to this somehow. Non-intent is created by default, and that indicates like something else, something that we didn't define here. And when we created our intents, we can go to utterances pages, and utterance is our examples. So what the workflow here, you log into LUIS, create some classifier, create intents, and you need to provide it with some data. You need to teach it, because obviously if you just type intent name by request, magic won't happen. It will not recognize that, oh, I already know some buy item intent, so I will recognize it by myself. No. You should provide here several, actually, not several, but a lot. It should be a lot of data. So for example, I want to buy a car. And I'm saying that this is a buy item request. After you filled your data, you should train your model. So you filled some data, and you actually training your model, so it will be ready for production. Because now it does, now it's ready. And after that, you need to publish your model to some endpoint. So to make it publicly available. Let's publish it, for example, on production. So publish it successfully, and let's go here and type some requests. I want to buy an apple, for example. And again, we can see that with some confidence level, in our case, it's 78% confidence. Louis sure that this is a buy request, so people who type this utterance want to buy something from us. Again, you can see some response here. So we have this top scoring intent. It's what things that hit the best score in our classification. Some other intents. So, for example, it's confident that it is support request on only 14%, for example. And if it could, it would extract from these queries some entities. So what it does, so it allows you to not only classify these sentences, but extract some useful information from here. So for example, if I type, I want to buy a car, I believe it will. Yeah, you see, we've got entities here. And these entities means are variables that we define. So yes, we know that we would like to buy a car. So first, we know that person wants to buy something. An entity can say what exactly he wants to buy. That was Louis. There are a lot of, again, different language services like text analysis, semantic analysis. It can understand what some particular fragment of text about. There are some translation. And also interesting service is content moderator. So let's continue with eShop. You have a comment functionality when people, for example, can comment some products. And you would like to remove all offensive comments. So content moderator will give you ability to do so and leave only non-offensive comments. So speech services, as the name as you might imagine from a name, it leverages some speech. Two basic things you can do with that. You can translate text to a speech and backward. You can say something and it can translate to text. But what I found more interesting in this group of services, so when you're translating text to speech, it pronounces it by robot. And if you like, you can create your custom voice. So those texts that you type will be spoken, for example, not by some robot, some voice, but by your own. Or if it's some business needs, or you can invite some celebrities, it can speak by voice of this celebrity. Let's go to this one. So, new tab. So what I actually did, I tried to teach it to read text using my voice. We will see how it succeeded, but in general, if you want to do so, again, you go to an admin panel and you import some data. So data should be, again, data, this is examples. Again, you need to provide a lot of example to this thing, so it actually could learn from it. And as more data you have, it's better. So, for example, you name some data set, some description to this data set, language, gender, and two main things. First of all is a zip archive with your examples. When you actually did recording in WAV format, and you upload transcription to these recordings. So it looks like yeah, like this. Yeah, I'll upload it. So, okay, you upload this thing. It passes through validation, so it could tell you how good your examples was, for example. And then you're creating your model. So here you imported all your data sets, and you can create model from different examples. To create a model, it took a lot of time actually, about half an hour it took half an hour for me to train with 9 examples. So I already did that and published. So here we can see what actually we've got. So let's type some hello. This is Nazari. How are you doing here? I'm glad to see you. And so how can I speak up? And no? Why? Please, no, not HDMI, these speakers, this voice. Oh, cool. And so, hello, this is Nazari. How are you doing here? I'm glad to see you.
Hello, this is Nazari. How are you doing here? I'm glad to see you.
So, this is as good as it is, but as you can see, there is some difference, let's say. But in theory, if you provide these a lot of data, a lot of voices and examples, it will actually be clean and more like you. And again, you can use this, when you publish, you can use this in your APIs. So, speech. And last service that I wanted to show you is knowledge services. What it is. It's trying to create automated question and answer system. So for example, you have some knowledge base, which, again, let's go back to eShop. You have some forum where people can ask different questions, and again, other people can answer them. So you can build your model using all these questions and answer, and it will learn from it again. And if it can automatically respond to some known questions, or not exactly. Again, it might seem that it's just using some string contains, but it's not. It's actually intelligent. If you ask a question in a different form, for example, it will recognize it. Q&A Maker, again, has admin portal where you can log in, create your knowledge bases. For this one, I didn't create my own. I used some examples from Microsoft, and this is example of a friend. Here we can see that we can type any question. So any question, and this is filter, add Q&A pair, come on, add Q&A pair, some question, and some answer. And you can provide a different, again, example, different forms of this question, and bot will, let's call it a bot. It will respond to you using these answers. Again, you should save your model and train. All these AI stuffs take some time to train it. So again, we'll talk about workflow later, but When it will be done, or I guess I have some published model, so I could try it here. This service will respond to you with answers on questions that you provide. So for example, hello. And it responded with hi. So it recognized that I'm greeting it, so it says hi back. And again, we can see a JSON response here. It shows us a different type of predefined questions and answers that it provided, again, with a score, with some score. So hello, how are you doing here? I'm doing great, thanks for asking. Thanks for conversation, bye. You're very welcome. So that was Q&A Maker 4. Let's go back to the slides. And this is already a use case. All these services could be used in a chatbot. So Azure has a separate service called chatbot. There are different types of it. It's a web bot, functions bot. What we've seen in Q&A, so it might seem like a chatbot because it responded in this manner, but this is actually not. Trick with a chatbot that you can add several knowledge bases to it, so it could learn information from a lot of places. And other things that it's actually programmable. You can use also language understanding services like LUIS for it to be able to extract some intents, and you can program it to react on these intents appropriately. Last Wednesday, it was 14th of November, Microsoft announced containers for cognitive services. Again, hi Lola. Containers not leaving us. You now be able to run these cognitive services as Docker images, as Docker containers, and it allows you not to do a request to an Azure, but run it on some isolated environment. This is brand new. Not all services supporting it, only few of them. I haven't tried it yet, but I believe this is really cool. Another thing that I wanted to talk really briefly, not exactly Azure, but something from a .NET stack. It's a library called ML.NET, machine learning.NET. It's actually a framework which allows you to build your custom machine learning model. So let's go back to cognitive services in Azure. This is some pre-built model. So if you need to extract faces from an image, you use cognitive services. But for example, if you need to analyze all your products on your eShop, for example, analyze some comments, ratings, and predict prices for future products, there is no Azure service for it. So this is something that you need to build by yourself. And to do so, we can use ML.NET. Currently, it's in a version 0.7. ML.NET team tries to release, make a release every month approximately, and it really quickly changing. So just a brief look to it. So what you do, for example, you have your data. Here I am using official Microsoft Hello World example for ML.NET. So this is Iris data, which will predict which flower we are trying to recognize, for example, by giving length of leap and other parameters related to flowers. So first of all, we defining our POCO class, and our class which with a prediction, so what we want to predict. It's a plain old CLR object. What we do next, we are creating our environment. We are loading this data And we are using text reader to define what columns do we have, what separator is, and so on. All main magic happens here. So we are creating our learning pipeline. All this pipeline, what it does, it extracting features of exact what feature we would like to use to train our model and to use on our model. We are defining some algorithm, and then we train in model. We train in our model, and after that, we are able to make some predictions on new data that it hasn't seen yet. So this is all C#, you can do it. And also, if I'm not mistaken, ML.NET is available on F#, if you're a fan of it. So you can try this one. And coming back to Azure, there are also two things. It's Machine Learning Studio and Machine Learning Services. What they about? Machine Learning Studio is a GUI. It's a very user-friendly with a drag and drop functionality, all this cool stuff. Its capability is similar to ML.NET, but except this is more mature and more tested. Machine learning services are relatively new, and it's more like, so again, you use Machine Learning Studio when you want to build something quickly and you're not really familiar with the topic. Machine learning services is more for those who are familiar with the topic, and it's more Python orientated. Yeah, Python is a great language for machine learning for nowadays. That's true. So it mostly integrated with Python with Jupyter Notebooks. So Jupyter Notebooks is also really cool software where you can run Python code, all this data analysis, statistic, machine learning there. It integrated with this, and you can use it. We talked about tools which we can use to do machine learning, but yeah, what is the most important in all of it? Of course, it's data. About 80% of your time when you do machine learning, you will spend with the data. About 20% you will spend with the code, approximately. So why data is important? Because data is what makes sense. What makes all of it valuable. What makes all of it to do what it's doing. Without the data, so machine learning, it's about the data by definition. We learn from existing data set to predict or to operate with it or based on it in the future. So what you do when you like to do some machine learning? First of all, you are getting your data set. More data is better because, again, if you get only a few data, you will get bad results like I did with the voice. But if I provided thousands of my recordings, I think it would be great. So you get your data, okay. Next thing that you need to do is to clean it, because obviously this is, so you get a raw data, which is not prepared for you to processing. What you like to do is to create, like for example, again, eShop, classic eShop example. You would like to predict prices on future products, and you have a prices, for example, in euros, in dollars, in bitcoins, anything. Obviously, you need to normalize it to one currency. And there are a lot of different examples, but you need to clean it. And second, maybe it is the most important stuff in machine learning. You need to split your data set in two. One, you will use for training. Second, you will use for testing. Why to do so? Imagine you have this massive data set and you feed all of it to your model. It will train on it, and then you will test it using the same data from existing data set. it is almost 100% that it will work correctly, that it will score, it will get a high score, because it actually data it's already seen, it's data it's learned from. What you really want to do is to test your model in real world example. And in real world, you will, it possibly that you will get the same input that you test, that was on your test, but it's more likely it's not. So you need to split it in two and see how data reacts on data that it's seen, and how your model reacts on data that it's not seen. You train your model after that, you test it, and when you see, basically after that cycle repeats. If you see something that you don't like or it's working not correctly, you just get more data, again you clean it, you split your data set, and so on. So the very last things, summary, let's summarize it. You don't need to be a data scientist to use machine learning in your business tasks. One of a great speaker, unfortunately I forgot his name, he said a great aphorism. I'm not a data scientist, but I know how to call a REST API. So this is what it's all. Oh, Tim Huckabee. Yeah, I remembered. Tim Huckabee, one of head guys who developing specifically Vision API. So it's really easy for us to use if we have some particular business task which require this kind of stuff. We just call our REST API, and again, this saves our time. We're not solving problem that already solved. We are focused on our particular business problem. What else? If you need your custom models, then you do need to have some knowledge. You do need to use, for example, ML.NET if you're using .NET Stack, Machine Learning Studio, services, and that kind of stuff. And remember about data. You need to get really, the more data is better. It's worth to mention also that you are able to create your custom Cortana skills. I assume everybody knows Cortana, so it's Microsoft digital assistants like a Siri, but from Microsoft. And it also leverages machine learning stuff. But if it cannot do something that you really want it to do, so for example, Cortana make me a pizza, for example. Cortana can do that, but there is an API, there is a documentation which you can read, and you can build your custom Cortana skill, Cortana make pizza, and it will do it whatever you program it to do. And very, very last thing, that you all seen that it's not ideal. It has some mistakes. It can't recognize something that is obvious for us, for human, but it's continued to developing, it's continued to grow. And it also depends on our compute power. So the more powerful hardware we will have, the more powerful all this machine stuff we can get. So again, for example, what Tim Huckabee once told about, they have a guy in the Microsoft that completely blind, but he's a coder. He works in Microsoft like a usual person. Again, I don't remember his name, unfortunately, but what they did, it's, I believe, not HoloLens, but something similar or something even unique for this person, some kind of glasses that were always connected to internet and use these cognitive services, especially image detection, if I'm not mistaken. And it could tell this person what's going on around here. But for now, so this algorithm, on the very beginning, it could recognize about 500 objects. Now it can recognize, nowadays, 2,000 objects. And again, this is because of compute power. When we have our more compute power, it could be 10,000s and millions objects. So this is also important. Thank you so much, and what questions do you have?
Спасибо за доклад.
Спасибо, интересный доклад. У меня несколько вопросов. Первое, по поводу хранения этого всего дела, особенно, например, по распознаванию образов, как это все соотносится там с GDPR и последними вот этими всеми законами. Потому что я не сильно верю, что Microsoft там никуда себе не тащит эти картинки. Это же могут быть там фотографии твоих юзеров или там какие-то случайных людей, про которые вообще сейчас там жесткие законы. То есть насколько можно быть уверенным, что это все будет, ну, как я понимаю, ты загружаешь датасет каких-то картинок, и оно тренируется на них, и только на них, да, или они используют еще какие-то данные?
Там получается какой прикол. Ты абсолютно прав, что, ну, типа, они хранятся. Они в любом случае в дата-центре хранятся. По поводу вот GDPR и прочее, опять-таки, Microsoft это все продумали. И там в чем фишка? У тебя есть специальный access key, ну, который я, собственно, ну, показывал его именно usage. Этот access key, ну, и это релевантно для всех сервисов. То есть они доступны, во-первых, только в определенных регионах, там West US, West Europe и так далее, и так далее. И вот каждый ключ выдается на регион. И вот, как говорит Microsoft, данные хранятся там, куда сбанден твой ключ, что позволяет тебе как раз, вот, типа, если ты там в Европе, то ты юзаешь какой-то там West US Key, West US Data Center, и оно вот там хранится, и теоретически оно это все удовлетворяет. Вот, кстати, вот одно из преимуществ вот контейнеров, то, что они вот недавно выпустили, то они сами говорят, что, мол, вы, если вам там супер важно sensitive инфу хранить, вы ее, ну, не храните в облаке, вы храните где-то там вот у себя, вот, где у вас контейнер.
Я могу какой-то свой необлачный сервис,
да.
Могу я развернуть?
Да, ну в контейнерах как раз. То есть это будет именно имидж, ты его стягиваешь, то есть опять-таки эта модель уже она натренирована, то есть все, что она может делать, это вот, ну, вот эти вот все ML-таски делать. А ты уже проводишь там свои кастомные данные к ней, и оно вот может уже с ними работать.
А есть у них в доках какая-то информация по поводу, какие там нейронки они используют? Ну, если, допустим, вдруг я там чуть-чуть шарю в этом, и я решил там сравнить с каким-то АВСом, там, кто лучше, там, или еще что-то.
Я такого не находил.
Просто black box, да, и все.
Угу.
Спасибо.
Это был очень интересный доклад, спасибо. Но хотел бы задать пару вопросов. Ты рассказывал о машинном обучении, но не уточнил, что это было. Имею в виду, это был какой-то определенный алгоритм, или это были нейронные сети, или что-то иное? На примере чего эти сервисы, что находится снова у этих сервисов, которые ты использовал?
Опять-таки, это немножко соотносится к предыдущему вопросу. Это black box, то есть какие конкретно алгоритмы, нейронки они использовали, непонятно. Но мы как бы можем быть там, с какой-то долей вероятностью, большой долей вероятности уверены, что, допустим, вот image-сервисы, language understanding, это, да, это deep learning, в котором используется, их фишка в том, что используются вот эти вот deep neural network, вот, на основе какой-то вот из них.
То есть ты не знаешь, какие еще архитектуры нейронных сетей использовались?
Нет.
Ладно, тогда еще вопрос. Там было, когда первые примеры с картинками, там как placeholder к этим картинкам было размер изображения указан. 1200 на 400 и что-то еще. Это было конкретно в примере. Да. Если ты загрузишь картинку другого разрешения, то работа будет хуже или такая же?
Абсолютно такая же. На самом деле здесь даже не 1200 на 500, и вот здесь, вот, по-моему, тоже не 700 на 150. Что происходит? То есть смотри, ты загружаешь какую-то картинку, вот, допустим, вот эту вот, где она там.
Я просто почему это спрашиваю. Есть конкретно модели нейронных сетей, которые ориентированы на определенный размер.
Ты в этом... Все, я понял. Да, конечно, безусловно, что качество самой вот исходной картинки, оно 100% влияет на результат. Вот, к примеру, вот эта вот штука, то есть мы уже видели, что оно не смогло распознавать некоторых персонажей, даже задетектить фейс на вот этой вот картинке. Мне кажется, если бы картинка была лучше, оно бы смогло это сделать. И вот опять-таки в детекте оно не смогло распознать вот какие-то другие штуки, типа там нос, уши. И вот если, давайте ради эксперимента попробуем, у меня есть другие картинки. Это тоже плохое. Вот это, по-моему, хорошее.
Здесь еще вопрос как раз-таки заключался в том, влияет ли масштаб картинки на возможность ее распознавания.
Влияет, да.
А также там у тебя еще был на примере, когда были запросы и ответ. Там у тебя было несколько запросов, допустим, с возрастом связанные. В чем конкретное отличие от какого-то, допустим, банального словаря, когда ключ значения?
С возрастом?
Там у тебя запрос типа...
question, все, я понял.
А по факту, то, что я там видел, это было почти один в один, как если у тебя был словарь значения, ключ значения.
Это, на первый взгляд может показаться, что так и есть. Я же говорю, такое ощущение, будто, на первый взгляд, там, словарь, контент какой-то, не machine learning. А на самом деле, я же говорю, то есть если я задам вопрос немножко по-другому, не то, то оно распознает. Да, вот в этом его фишка. И опять-таки, чем больше ты на вот данный типа ответ ему примеров дашь, тем больше оно сможет, тем лучше оно на основе него научится.
Понял. И последний вопрос. Ты привел как пример библиотеку ML.NET. Ты можешь как-то ее сравнить с TensorFlow, который написан под JS и под C#? Там тоже есть ответвление. И с Accord.NET.
Насколько я знаю про TensorFlow, то есть, ML.NET на самом деле в сравнении с другими более, скажем так, зрелыми библиотеками и прочим, он уступает. Конечно же, уступает, потому что это, во-первых, новое решение, новое конкретно вот от Microsoft, то есть это они вот пилят такую штуку для вот именно .NET стека, потому что вот опять-таки тот же TensorFlow, там Python, типа ты можешь делать просто много крутых вещей на TensorFlow и Python, но если ты C# разработчик и хочешь, оставаться... то есть они в таком вот ключе его разрабатывают. Более того, они вот, начиная с версии 0.6, добавили поддержку. Там какая фишка? Ты можешь создать модель в TensorFlow, обучить ее, заимпортить, как в ML.NET и юзать уже дальше ML.NET-овскими средствами. То есть, они даже вот в таком ключе работают, что типа collaborative,
Все, тогда на этом все. Спасибо.
Спасибо.
Спасибо вам большое за доклад. Было несколько вопросов. Один из них, кстати, перекликается вот с этим последним по поводу ML.NET. Чем, я так понимаю, кроме .NET-овской реализации, он ничем особо не отличается от CNTK, которая тоже от Microsoft и тоже на нейронные сети направлена.
Пока что по факту да.
Хорошо. Потом по поводу вот этого Lewis-сервиса. Какого примерно размера датасет нам нужно приводить к операциям, чтобы он адекватно обучился? То есть или это 10 вариантов запроса на один метод, или 100, или там 1000 может?
Отвечу, как всегда отвечают на вот эти вот штуки. It depends.
Логично,
Потому что,
логично.
да, это, опять-таки, вот в этом и заключается фишка machine learning, что вы в основном работаете с датой. И типа понять, как много вам нужно входящих данных, это только берешь и пробуешь. Типа такого.
Окей. Хорошо, спасибо. И последний вопрос еще. Я так понимаю, довольно очевидно, что, скорее всего, всем препроцессингом данных занимаются уже эти сервисы внутри. То есть нам не нужно, например, ванхотом кодировать текст перед тем, как его отправить в этот REST API. Мы просто чистый текст туда шлем и все.
В этом и прелесть, да, что мы никак не думаем, что типа как там его трансформировать. Более того, Луис, даже если мы вот посмотрим сюда, я типа вбиваю uppercase, оно его само трансформирует в lowercase, опять-таки для своих каких-то нужд. То есть, грубо говоря, оно само знает, что ему надо, оно типа это и делает. То есть вы вообще не заморачиваетесь. в этом плане.
Хорошо, понял, спасибо большое.
Последний вопросик. Время поджимает.
Спасибо за доклад большое. Меня заинтересовал Search API. Вот что именно конкретно делает эта штука? То есть она ищет конкретно только, ну, как Bing, да, то есть в интернете ищет именно URL, или возможно ли как-то ее настроить на свои конкретные данные? Например, допустим, самый простой пример. Всегда нам, почти всегда во всех приложениях нужен поиск. И использовать contains, ну, это как-то уже не очень красиво, и все хотят, а вот хотим, как в Google, да, говорят. И возможно ли натравить вот эту вот штуку на свои данные с тем расчетом, чтобы оно искало именно конкретно в твоей базе данных, там, в конкретных твоих примерах, то есть, ну, как-то вот.
Хороший вопрос. На самом деле я стопроцентного ответа не знаю, но я более чем уверен, что можно. У них же даже в Azure есть специальный типа свой search-сервис, который, ну, мне просто где-то мельком пробегало перед глазами, что он тоже, типа, вот, ну, может, типа, как Cognitive и прочее, и, возможно, даже, ну, короче, думаю, что можно. Стопроцентного ответа не дам, но, скорее всего, да. И в Microsoft, мне кажется, такую фишку бы, ну, предусмотрели, потому что, ну,
Было очень удобно.
ну, да.
Все, спасибо.
Хорошо, всем спасибо за вопросы. К сожалению, время уже подошло к концу. Я думаю, всех, кто заинтересовала эта тема, смогут Назарию подойти.